Guys, let's do this quadratic theorem today, and it's a very important theorem for scholarship exams and other maths competitions as well. So let alpha and beta be the roots of a quadratic equation ax squared plus bx plus c. Then alpha plus beta is equals to minus b over a, and alpha beta is equals to c over a. So that is what we need to prove. Okay, so let's start with the alpha beta. So because they are roots, we can say the values of alpha beta of alpha and beta are, we know that with the use of that formula we can find those values. So r minus b plus minus square root of b square minus 4ac over 2a. So alpha could be with the positive value, beta could be with the negative value in it, right? So we can say, hence, we are trying to find alpha plus beta. So let's do that. So hence, alpha plus beta will be equals to minus b plus square root of b square minus 4ac over 2a plus minus b minus square root of b square minus 4ac over 2a. Okay, so now we try and simplify as much we can. So we will do minus b over 2a minus, and then we are doing plus square root of b square minus 4ac over 2a, plus minus will be minus b over 2a, and then minus plus is minus square root of b square minus 4ac over 2a, right? So here we can see that we have minus b over 2a minus b over 2a here, which are same. So we can write them as minus 2b over 2a, right? And the other one, we have plus b square over 4ac and minus b square over 4ac, and that can cancel each other. So that will cancel. We are left with nothing there. So when we simplify this, we have minus b over a, and that is what we had to prove. So alpha plus beta is equals to that, and this is our first proof. All right, so hence proved. Cool. Now we'll similarly do the next one, which is alpha multiplied by beta is equals to c over a. So now we'll have to multiply these. All right, so let's do that. So alpha multiplied by beta is equals to minus b plus square root of b square minus 4ac over 2a multiplied by minus b minus square root of b square minus 4ac over 2a. Okay, now if again spread into two parts, we will have minus b over 2a plus square root of b square minus 4ac over 2a, and the next bracket is minus b over 2a minus square root of b square minus 4ac over 2a, right? So here we can see that we have x plus y and x minus y, and we know that that is equals to x square minus y square. All right, so we will use this algebraic identity and solve it. So now we will be left with minus b over 2a whole square minus square root of b square minus 4ac over 2a whole square. If we solve it, we are left with b square over 4a square minus square root and square will cancel. So we are left with b square minus 4ac over 4a square. Right, now we can take 4a square common. So we have 4a square common in the denominator, and we will have b square minus b square minus minus plus 4ac. B square and minus b square is 0. So we have 4ac over 4a square. 4 and 4 cancel. 1a will cancel the a on the top. So we are left with c over a, and that is alpha times beta. All right. And that is what we had to prove, that alpha times beta is c over a, and that is what we have got here, right? Hence proved. Cool. Now we'll do a couple of questions with it, so stay tuned. All right, so now let's do this question where it says express ax squared plus bx plus c is equals to 0 in terms of alpha and beta, where alpha and beta are the roots. So alpha and beta are the roots. All right, so let's start that. So we have ax squared plus bx plus c is equals to 0. Okay, what we do is we divide the entire thing. If we divide the entire thing, or dividing both sides by a, so we will get x square a over a, let's just write that down, plus b over a x plus c over a is equals to 0 over a will be 0, right? So we are left with this. Now a will cancel, right? So we are left with x square plus b over ax plus c over a equals to 0. In our previous question, we have found that alpha plus beta is equals to minus b over a, right? And alpha times beta is equals to c over a. Yes? So if we just check, we scroll back on, alpha plus beta is equals to minus b over a, and alpha multiplied by beta is equals to c over a, right? So if we substitute these two things, if we substitute it back in this equation, we will have x squared. Now because it is minus b, we will have minus alpha plus beta x, and then c over a plus alpha beta is equals to 0. All right, I hope this is making sense. Yeah, and now we can write it into two brackets. So we have a as common, or a, because we divided by a, it doesn't matter, we can have a common. We will have x minus alpha, and x minus beta is equals to 0. Does that make sense? Or a can go there and divide by 0. So now we have converted that entire thing into alpha and beta.